Here's a fun puzzle. Using the digits 0 to 9 each exactly once, let's create a 10-digit number where the first digit is divisible by 1, the first 2 digits as a whole number is divisible by 2, the first 3 digits as a whole number is divisible by 3, and so forth. Let's see how we can do this. First, we can already place 2 digits. This 10-digit number has to be divisible by 10, so only a 0 works here. And the first 5 digits as a whole number has to be divisible by 5, so only a 5 or 0 would work here. And 0 is already placed, so that means this digit has to be a 5. Now, for a number to be divisible by 2, 4, 6, or 8, the last digit has to be an even digit. So let's place those possibilities in these positions. And that means the remaining odd digits are in these other positions. Now, let's take a look at the divisibility rule of 4, which says if the last 2 digits as a whole number is divisible by 4, then the original number is divisible by 4. And here are those possibilities given these digits. Now let's look at the divisibility rule of 8, which says if the last 3 digits as a whole number is divisible by 8, then the original number is divisible by 8. And here are those options given these digits. Now notice in positions 4 and 8, the only options are 2 and 6. So only 2 and 6 can be in those positions in some order, meaning 2 and 6 cannot be anywhere else. So let's look at position 6 and eliminate the options where 2 and 6 can be an option there. And here are the options. Now let's take a look at the divisibility rule of 3, which says if the sum of the digits is a multiple of 3, then the original number is divisible by 3. And here are those options. Now let's take a look at the divisibility rule of 6, which is the divisibility rule of 2 and the divisibility rule of 3 at the same time. For 2, we don't have to worry about the last digit being even, that's automatic. So let's just check to see if the sum of the 6 digits add up to a multiple of 3. We don't have to worry about the first 3 digits because we just did that. The sum will be a multiple of 3. So let's find the combinations of the 4th, 5th, and 6th digits so their sum is a multiple of 3. And we only have 2 options for that. Now let's combine the 4th through 8th digits, making sure that there are no duplicate digits. Alright, now let's combine the 1st to 3rd digits and the 4th through 8th digits, making sure that there are no duplicate digits. And we are down to 10 options. So right now, make a guess at which one you think it is, because there's a 1 in 10 chance that you are correct. Now, we haven't touched the divisibility rule of 7 yet, and to be honest, I think it's too complicated to actually implement, so I'm just going to use a calculator to see which of these numbers is divisible by 7. And only one of these is divisible by 7, and the only digit not represented here is a 9, so we can place the 9 over here, and we know that this number is divisible by 9 because the sum of the digits is a multiple of 9. So the only number that works here is 3,816,547,290. So, was your guess correct over here? Let me know in the comments.